Welcome to our lecture online. Now let's take a look at differentiating some exponential functions in the form of e to the x. So here we have two simple examples. First we have y equals e to the 5x, and then we have y equals 5e to the 2x cubed. All right, how do we do that? Well, the interesting part of the exponential function with the base e is that when you take the derivative, for example, y prime, which is the same as dy dx, that is equal to the exact same thing. So the first thing you do is you repeat what's there, you write it down again, e to the 5x, but now you multiply that times the derivative of the exponent. The exponent being 5x, when you take the derivative of 5x with respect to x, you simply get 5. So I'm going to write it like this, times the d dx of the exponent 5x. So that's to accentuate that we first repeat what we have, and then we multiply that times the derivative of the exponent 5x. Now this becomes e to the 5x times 5, because the derivative of 5x is 5, and then we typically write the 5 first, so we write 5e to the 5x, which is the derivative of our exponential function. So now that we know the technique, we're going to do the exact same thing here. Notice we have a constant in the front, so we can just go ahead and ignore that, leave it out. So y prime, which is equal to dy dx, is equal to, we write the exact same thing we have before, so we have 5e to the 2x cubed, but now we're going to multiply that times the derivative of the exponent, so times the d dx of 2x cubed. So now we know how to take the derivative of that, so that goes as follows. We have 5e to the 2x cubed times, we take the exponent and multiply that times the constant, so 2 times 3, which is 6, x to the 1 minus, the exponent minus 1, which is 2. So 2x cubed, we take the derivative, we get 6x squared, and then typically we put that in the front. 5 times 6 is 30, so this becomes 30x squared times e to the 2x cubed. And so that would be the derivative of our initial function. Again, the technique is exactly the same. It doesn't matter if it's a simple one like this or if it has an x cubed in the exponent. We use the exact same technique to find the derivative. And that is how it's done.